Welcome to our session on building AI ML web apps with Streamlit. My name is Ankita and I'll be your moderator for this session. I represent SpringPeople, India's leading enterprise training provider, and it is a real pleasure to have you with us today. Now, we all know artificial intelligence and machine learning are powerful, but without simple interfaces, their true potential can sometimes feel limited. That's where Streamlit comes in. It allows you to quickly take models and transform them into clean, interactive, user-friendly applications with minimal effort. In this session, we will take you through the journey of building and deploying AI and ML applications using Streamlit, from setting up your very first app to enabling real-time predictions and even deploying to the cloud. You will see how ideas can be converted into functional and shareable applications. We are delighted to have with us Ms. Amuda, an experienced corporate trainer with more than 9 years of expertise in Python, Java, artificial intelligence, machine learning, data science, Power BI, and many more technologies. She has worked with respected organizations such as GE Healthcare, TCS, Volkswagen IT Services, and Comcast. Now, before we begin, just a quick note. If you have any questions during the session, please place them in the Q&A box. They will be addressed during the Q&A segments towards the end by Ms. Amuda. With that, let us get started. Over to you, Ms. Amuda.
So I'm completely honored to have this opportunity to share my knowledge. So today the webinar is about from model to app, which is building the AI ML web applications with the Streamlit. So artificial intelligence machine learning, which means that it is the broad field of making the machines think and act like the human beings. So, example, I can say a self-driving car that is perceives the environment and it helps to take the make the decisions and also drives safely. This is what the complete artificial intelligence system. So coming to the point of the machine learning, so which means that focuses on making the machines learn from the data without being explicitly programmed. So I can take instead of bending the rules, we give the machines examples like data plus outcomes. From that it learns the patterns to make the predictions or to make the decisions. So this is what the complete AML. So what is the link between the AML and the Streamlit? So see, you can in AML you can train the models to predict or to classify or to generate the results. So examples I can say like classify the emails as spam or not spam, or predict the house prices or sentiment analysis or the text. So these are the AML creating models. But after the training, the model is just a code only, or code plus the weights. So to use it interactively, we need a way for the users to give the input and to see the output also. So to see the input and output, we need this Streamlit. So this Streamlit brings the models to the life. So it is the bridge between your AIML model to the end user. So it let you build a simple web applications around your model without needing any front end or back end coding. So just we are going to wrap our Python ML code inside the Streamlit functions, and instantly we are going to get an interactive UI user interface design. So this is what we are going to do. So now let's see how it is happening, and today we are going to discuss with the hands-on also with this. Okay, let us move on to the next page. Okay, so introduction to the Streamlit. So Streamlit is actually an open source Python framework that lets you to turn your Python scripts into the interactive web applications. So using this Streamlit, we don't need actually any web development knowledge, like we don't need HTML, CSS, or the JavaScript. And just you're going to write a simple or normal Python code, and you're going to add some basic UI components, user interface components. Like here, we are going to add some text boxes, sliders, buttons, file upload, etc. that we are going to see hands-on. So with one line of code, that's it. So easily you can integrate with the pandas, with NumPy, Matplotlib, Seaborn. Even you can use Plotly. Even you can have the scikit-learn, TensorFlow, etc. So these libraries you can use, and it is good for, or it is great for the data visualization also, the dashboards, ML model demos, everything that we can do, and even we can have this live updates also. So whenever you save the script, we can automatically update, like whenever you save the script, like no server restarts needed for this. So there are so many widgets are available to use this interactive UI elements like buttons, sliders, file uploaders, etc. So after once it is done, you can have the deployment also. It is free hosting on the Streamlit community cloud. So it can be deployed on Heroku also, AWS if you want, GCP or Docker, that is also you can do it. So next is why we are using the Streamlit for the AML apps, like I already have mentioned with the link. So for the data scientists or the ML engineers, it is actually a very fastest way to show your work, right, as an interactive app. So here, using the Streamlit, we don't need to learn Flask or Django or JavaScript. It's perfect for building. So building any machine learning demo applications or the data dashboards, or you can use it for the quick prototypes or the internal tools, everything that we can use it. So we are going to see everything. And this Streamlit, which means that it is going to be a Python script. It is going to change a Python script into any interactive web application in just minutes. So this is why we are using Streamlit for the artificial intelligence ML, and very importantly, it is for quick prototyping of the models. So normally, once you train any machine learning model, you're sharing it, that requires like a Flask or Django code to make API and also building a front end. So with the Streamlit, you can go from a Jupyter notebook to the working web application in just a minute. Like say, for example, like today we are going to discuss with the diabetes prediction. So you can show your trained model in an interactive applications where the users upload any CSV or any image, text, or the model predictions instantly. So you can do lots of hands-on experimentations. So it is completely very interactive. It is providers already we have mentioned with sliders, drop downs, the buttons, everything. So you can try different models and you can visualize the results also. Okay, like say for example, I can say you can adjust the learning rate or the number of layers with the sliders, and you can see the result lively. It is just, you just need to refresh, that's it. And there is a very good visualizations. It is good to work with Matplotlib, Seaborn, Plotly, etc. And very perfect for showing the EDA, which is exploratory data analysis. You can use a model performance and the feature importance, everything over here. And this is very user friendly for the non-technical stakeholders. Not everyone can read the Python code, or not everyone can understand the Jupyter notebook. So this Streamlit turns your work into a clean browser-based app. So any managers or clients or even the students can interact with your AML model very easily. So very easily deployment. So once you build your AML app, you can deploy it freely, as I mentioned, with the Streamlit Cloud or host on Heroku, AWS, or the GCP thing. So anyone with a link can use your model. So no complex infrastructure needed in this.
Hello, Amuda.
So yes,
Yeah, sorry to interrupt you. I don't know. I think the slides are not moving.
no, I'm going
Acha,
to do with hands-on. So I'm just
acha,
preparing for the explaining this why Streamlit for AML apps.
acha. Okay, sure. Fine. Okay.
Okay. So, and this is very good ideal for the teaching and the training. So it is perfectly good for hands-on AML learning also. So it is very good. There are so many use cases available with the Streamlit, and you can also use this with NLP, computer visions. You can use with predictive analysis, chatbots, LLMs, etc. So we are going to prepare this. So it is open source Python library. So designed for creating the data and the ML web applications very easily. And as I mentioned, there is no front-end coding required like HTML, CSS, or JS not needed. And this is also used by the data scientists, ML engineers, and the researchers. So everything is all about the Streamlit. And the next slide is yes. So, like as mentioned, it is very simple and Pythonic, and we are using the sliders, text inputs, file uploads for the interactive widgets, and it is very, very easily deployment. Like is Streamlit Cloud or Docker, we can use it for the deployment, and it is great for the prototypes and the production ready apps. Okay, and it is also very good, very, very best for the visualization support. So you can have the real time visualization support. We can use it. And the typical workflow, we are going to first load our ML model or train our ML model. Then we are going to do some pre-processing data inputs using some pandas. Then we are going to build the Streamlit UI components, and we are going to interact with the predictions, like you are going to integrate model predictions with the user interface, and you're going to deploy and share. This is what the complete typical workflow, and we are going to deal with this. Yes. So first, yes, preparing any ML model. So first we need to choosing any data set. Maybe the data set is anything, like it can be labeled with a structured, well-structured data with a label, or unstructured data without the label. So we can predict using the structured data. We can predict the data. We can predict the efficiency. We can predict the some end users. We can predict some end users result. But using this unsupervised learning, we can find the pattern. So this is how the data sets, the different kinds of data sets we are using. So here training model is like using the scikit-learn or TensorFlow, PyTorch, like everything that we can use to train the model. And after that, you can save the model using the pickle or joblib. And we need to ensure that pre-processing pipeline is included also. So pre-processing is very important in any data set preparing model. And yes, so we are going to install the Streamlit and we are going to run the applications. So first we need to, like I am using in the command prompt. Let me go to the command prompt. This is my command prompt, and first I'm going to install the Streamlit. So the installation of the Streamlit can be happen by using this command called pip install the Streamlit. Okay, so once the pip install Streamlit has done, so the complete packages it is installed. So once the complete package is installed, and make sure that the Streamlit program should be false on the same location. The location is very important, and you need to install where you are going to use this Streamlit. So this is installation is done. So once the installation is done, yes, this is getting ready. Now this is you can view your Streamlit applications in your browser. So yes, I can see. So this is my Streamlit applications. I can see my Streamlit. This is my Streamlit applications. So before that, I'm going to open some idle, which is I'm going to use Python basics idle of some stream new.py. So in this idle, I just imported the Streamlit as st. So very important, we need to import the Streamlit. So this Streamlit is, it is, we can able to access all those widgets. We can use all the components, UI components, everything from the Streamlit by just importing this line, import Streamlit as st. So once it is done, like I'm going to, after this, I'm going to do with data analysis. Before that, I am just going to give some head setting the page configurations, and the page configuration name is Streamlit Web Applications. You can also set something else, Streamlit Applications, demo application, like that. I'm just going to mention. Okay, so once it is done, and I'm going to save this. So this header page, this is web page. So I can set this like header page so that you can understand what is a header page. So this is header page, and the first topic I'm going to give the subtopic as I'm going to use the logistic regression. So maybe I'm going to give my project name logistic regression, or I can give some diabetics prediction using logistic regression. Diabetes prediction using logistic regression as my subheader. Okay, so I'm just saving this, and now I'm going to run the Streamlit command through the command prompt. So here After installation, so we are going to run the Streamlit. So this is in the desktop. My Streamlit application is in the desktop. So I'm going to run this by using the Python. Okay, m Streamlit run steamnew.py. Steamnew is my file name. The run is the command which is going to run the Streamlit. Okay, so Python yam Streamlit run steamlitnew.py. So once it is run, so I'm just going to refresh this. It is already, I've just created. It is, yes, already it is running. So I'm just refreshing it. You come to know what is this. So now it has refreshed, and now this is the Streamlit header page. So I just mentioned, so this is the Streamlit header page. We just mentioned in this Streamlit header page, this is the header, and the subheader is we have given the title as diabetes prediction using logistic regression. Okay, this is how the heading you can give, and the page configuration, the title is Streamlit demo applications. So I have given this Streamlit demo application as here. So Streamlit demo application is the web application name. So name of the web application. So next we are going to see some more UI components of the Streamlits. So let me take it from, yes, I'm having everything in a document. We can do it one by one. So after this thing, so we can also use some latex. This latex is used to execute the formula. So we can use some formula based on this. Let me have this formula, like I'm going to do with some formula. So this formula, by using this st.latex y is equal to mx plus c, I'm just saving it. So you can refresh and you can check it. I'm refreshing it, and this formula is going to be done. So y is equal to mx plus c. This is the formula format. So this is latex, we can use it. And we are going to use some markdown text format. We can use caption. So everything that we can do it. So I'm just going to have this. So let's save this, and I'm just going to execute this here. So you can check now. We can have the text format. We can have this with this italic format. We can have this normal text format, and also we can use this a caption format also. This is a very important like basic UI components, and we are going to use it now. We can do some codings also. You can give Python coding, C, C++, whatever you want, and you can type the program coding. Okay, yes, I'm just going to type the program coding here. Let us do this, and I'm saving this. So this is a Python program, normal Python program. I just wanted to print this as Python program in the application. So I'm just mentioning this language equal to Python. So I'm executing this. We can have the Python program like this. So this is a caption, like it is completely a Python program. You can have Java, you can change the language equal to Java, you can change with C, C++, all the other languages, and you can check the result of this. And next I'm going to read the data using the pandas. So I'm going to get the diabetes CSV. So data, read CSV of this diabetes data, and this printing the same. Okay. So this is, I'm using this pandas. I'm going to read the data set. Okay, and let me save this, execute this. So now I just read the like all the data set. My data set is this. I'm just storing the data set in the desktop of the same location. So the data set name is diabetes TS. Let me open it in the desktop. The name is diabetes. So this is my data set. So in this data set, we have pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, age, and the outcome. So with these given factors, we are going to predict whether the person is affected with the diabetes or not. So this is what the prediction that we are going to do now. So this is the data set. Have read the data set using this pandas. So in the Streamlit application. So using this pandas, so pandas is this, once I'm importing this pandas, I have read the CSV file, which is diabetes CSV, and I'm just, convert this back into the data frame. Okay. So this data frame, you can also see it in the table view also. Instead of this data frame view, you can have this table view also. I can show you it in the table view. Let me save this and refresh this. So this is the like normal CSV view. You can download, you can search something, you can give some full screen, you can check it. So all these things you can do. And now we are going to see it in a normal table view. So it is taking time for refreshing. And this is the normal table view. Okay, you can find it normal table view. This is not a table view. This is the data frame, and this is the table view. You can see the differences. This is the table view. You can check whatever you want. So all the data set are available. A complete data set is available here. So I've read the CSV file right now. Then what I'm going to do is I'm going to add the widgets. I'm going to add the buttons first. So let us have some submit button. We're going to do some submit button. Let me execute it. It's one all the time refreshing and it is taking some time to refresh. This is the data set, and now this data set is ready. Here it is. Okay. This is the button. So now the submit button is ready. So I can do some submit based on this button. So this is one of the widget, very important widget. Next, we can have a checkbox widgets. So we can have some different with a submit with the different things, and we can have this radio buttons also together. I'm just going to do it with along with the checkboxes with the radio buttons also. I'm going to save this. Let me execute this. So I can able to see this complete checkbox list. So this is the button. Now this is the checkbox. I can check. You can use this checklist. So a complete checkbox list you can do with the Streamlit widgets, and this is the radio button. So you can choose anything else so that we can do it with this basic uh, Streamlit comments. So next we are going to deal with you can also execute some of the format. You can use XML format or JSON format that we can do it. So we can print this JSON format now. I'm just going to execute this. Sometimes to refresh it is because of the big data set we are having, holding a very big, huge data set. Right? And this is the JSON format. After this radio button, we can have this JSON format. So this is the JSON format we can do. Next, we can have the column. We can set the columns, we can set the matrix values using the columns so that we can do it. So I'm just going to make some matrix values. Set some matrix values using the columns, creating the columns first and setting the matrix values of these columns. And I'm just saving this. Let me execute it. It is refreshing and okay. And this is the columns. So this is column one. Column one is AAPL and the speed I have mentioned. So this is with column one. This column one has AAPL and the speed I have mentioned as 70 degree, I mean 70. And with that 4 percentage, I have mentioned some metric increment. And the next is with speed, with the next column with metric is speed, and it is 90 mph have mentioned, and with 10 percentage of increment that have made. So this is what column one and column two. So I can set some two columns here. If you want, you can change the alteration of the columns. Like you can change multiple n number of columns here, and you can also set the values of the same. Fine. So next we can have, like I can set some three columns, and I can set some more column for the same data also here. I'm saving these things and I'm just executing it. Let me, okay, for this inconvenience, let me make one thing. I'm going to, let us put some comments this one. I'm just commenting right now. I'm commenting right now this news because of this thing. I'm just commenting. But I can access very fastly. So I just wanted to know it. Okay, fine. So it's okay, fine. Some unpacked values of column one, column two. I need to mention this for call three. I didn't mention here call three. So let's have this call three here. Saving those and executing the option. So you can have some three columns together. Like if you want, you can have the multiple columns also like this. So this is how we are going to create a column. And now we are going to have some select box. Selecting the columns based on that, we are going to select the box, and based on the columns, you can also write some variable names if you want, you can do it. So selecting the columns. Let me execute this by selecting the columns. Okay. Okay, data is not defined. Fine. I need to mention this data. Of course, we should have this data. Only this view is enough, not the table view. Let us have this view alone. And this is the list of values that we are having. So we selected this by using the list of data in the columns and the select box. You can choose any columns here, and you can write this attribute is selected by that particular user. Like you can select some pregnancies or glucose, whatever maybe you can have. So I'm just selecting this glucose. You can select this glucose. So from this you can select glucose, or you can select this insulin. So you can have this attribute selected by the user, insulin. So this you can able to do it by using this select box. You can select something, some columns, and you can also write the variable of the column names also. And next we are going to deal with the text boxes. Let us have this text box. Along with the text box, I'm going to give a button also, and I'm going to give some condition based on this. Okay. And in this thing, so I'm just given some two columns. With the two columns, I'm going to enter the number one and enter the number two. I'm going to add. I'm going to paste some button for this addition, and during addition, it is going to print. So it is going to write if the sum of A and B is something we are adding, the A of B is like A plus B. It is going to execute. If submit button, if we did some submit button, so this is going to be happen and I'm just executing it. So this is the addition. So number one, number two, two columns already. Now I can give some number like 11 and I can enter the number for this number two, something like that. And I'm going to give the submit button at. And once if the submit button is done, I can give some value for the some 0.11 with 0.21 will get some value of 0.32. So this is what the buttons actually this is for the text box and we can also do some operations over the text boxes. And now the another important widget is slider. We have already mentioned about it. So this slider we are having given with the two columns, column one and the column two. And with the two columns, we are going to make some submit. We are going to check it with the addition. I'm going to give some addition of this. So the slider, let me save the slider and let me execute this. So you can enter the number, whatever the number that you wanted, basically with a slider. Okay, enter the number two, the range you can give, and you can click on this. I'm using this checkbox for the addition. You can do with some buttons if you want, and the both addition of A and B is some A-like. So you can give any range of values that we can. I have given some the range between 1 to 100. Here it is range between just a 10 only. So you can use it any of the ranges that you whatever you want. So I've changed here. Maybe I'm going to change the ranges here. So it is starting from 0 to 100 and I am going to reach with some 10 numbers it is there. And here it is 0 to 10. Like if you want, you can change it up to some 50 also. Like you can have some ranges here. So you can do. So it is 10 by, it is increasing by 10, 10, 10. Now let's have the slider. It should increase. See, it is increasing by 10 by 10, 10, 10. It is increasing. And you can check this up to 50. It is there. You can do the checklist and I'm getting this number. Okay, so I think we have done with the sliders. So next we are going to discuss with the multi-select. We can have the multi-select options also with multi-select columns. We can select multiple columns also together. We can save this multiple selection option. Executing it. Yes, and I can able to see this multiple selections. So you can choose any variable. I'm choosing anything like diabetes or something. You can select multiple. See, I'm selecting multiple options. See how I can able to see diabetes, pedigree, skin thickness, blood pressure, insulin. So these are some multiple options that I can select by using this multi-select widget. So in this Streamlit. Next, I'm going to discuss with another widget, which is images, very important. So for this image, we need to definitely import another another thing which is PIL library. So this is very important. So from PIL, we are importing this image. First, we are going to import this library. So after this, we are going to take the images. So this is image, showing the image, and I'm selecting some image from this. This is randomly, I've selected some image. You can also use some image. You can print some image here. I'm going to select this. My image option. Okay. So I just did this image. You will get this image. Okay, so that you are having some image, so randomly selected by images this, like you can display some images, whatever that you want, based on this location, you can have it. So this location is very important. So I've just mentioned it from the location, and you can give this location and you can edit your images, whatever you want. And let's have something else with the charts. We can do with charts here. So the charts, by using this column one and column two, we can have the charts. So also we can plot it by using the scatter plot. We can do plot also. So let's copy this. So before doing this plotly, let me first do this charts alone. We can make it charts first, and then we are going to do with the scatter plot. So for this, we are going to import another library which is plotly. Importing this plotly and this graph objects as yes. Plotting this, and I'm saving this, and let me execute here. So that we are going to have a complete chart about this prediction. This is the chart. So you can choose the target, like whatever the target that you want, you can have based on the glucose, based on the pregnancies, based on some age you're calculating this. So this is x-axis, which is age, and this y we are going to select with the like pregnancies. With this, we are going to calculate the glucose of this. So I'm going to select some pregnancies based on this pregnancies, the glucose, and I'm going to calculate the skin thickness range. So this is how the skin thickness range. This is what the scattered plot, and you can plot any kind of plots here, like you can use bar chart, you can use pie chart, you can use count plot, all these things are different kinds of plots over here by using this plotly. Also, you can use the representation on maps also by using this plotly or folium plotly, you can done. This can be done. So also you can select another target, whatever the target is, like based on the outcome, definitely we are targeting. So based on the pregnancies and the glucose, like the target is, so the 1%, like 1 to 0, you can have the eligibility of the the diabetes prediction that you can have. So this is a sample web applications. So this is how the web application is going to be. This is the project. So the complete project you can have it on the web application. But in the case of AIML, if we are searching about the AIML, the scenario is different. Like we can have the databases our predictions, the data set is different. So this is our data set. Maybe we can have some diabetes prediction like this. So this is the complete AML. It is just a code. It is just a code. We can have this just code. We are having just a code. We read the data set using this pandas, and we are doing some basic analysis over head, shape, the describe, the value count that we are going to, and we are accessing with the mean value. And this is the data and the labels that we can manage with print X and Y, and we can do some standardization where we can do the normalization of the data. And so after standardizing the data, after doing some normalization of the data, we can fit the data into the model. And once it is done fitting, yes, of course, we can do the transformation also. So all the category, if there is any categorical value, it is going to be converted into the numerical values, etc. So that it is completely normalized. It is now ready to do the process. So we are after setting this, segregating this X and Y, which is input and output. So we are going to do the train test split where we are going to testing and training the data set. So here the test size is around 0.2, which means that we are going to give some 20% of data size for the testing and remaining 80% of the data size for the training. So this is what we are going to do. And in this case of stratify, which means that we are going to arrange in some order. So using this classification related supervised learning algorithm. So this classification data set needs the stratified to arrange in an order, and the random state we can maintain it from the range of 2 to 42. And now we are printing in. This is for just checking the shape of the training and the shape of the testing purpose. And now after that, we are going to do the training model. So this training model is completely deals with the important, very important and good fit model, which is support vector machine. So we are using this linear for this SVC classifier. And now I'm completely fitting this training data to the SVC classifier. So it is done. And now we are going to check the model evaluation. Since it is the classifications, we are dealing with the accuracy score for checking the predictions of the training data and for checking the testing data. So once the accuracy is done, so this is the training data accuracy and this is the testing data accuracy. Yes, it is 0.78. It is not the very good fit. It is the okay, decent fit. I can say it is not the best fit. Maybe it is not the worst fit also. It is the okay fit now because 0.7 is not that worst, and 0.7, 0.78, and this is 0.77. Okay, more or less the prediction of training and the testing is similar kind of training is done here and the testing is done here. Next, we are going to check whether this predictive system is okay or not. It is perfectly predicting or not by making a predictive system. This is just an expert system, we can say. So this, I'm going to give the input data. Input data is I'm going to give the same range of input data with this: pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, age, and outcome. So this is the output. Outcome is output. So up to this age, I'm going to give the input. So I'm just giving the input by reshaping it. So the input has given with the same ranges, and yes, it is standardized the input data after transformation. So once it is done, we are going to predict it. So, and if the prediction is equal to 0, of course the person is not affected with diabetic, else it is going to be diabetic patient. So this is what the complete project. This is a 1 week code project, and we are going to completely change this project into the application format. So where we are using the formula is also very perfectly, where we are using this data set, we are reading the data set, we are doing some shape, we are doing some value count, everything, all the things completely into one web application, so that in a very interactive mode we are going to calculate. So with the interactive mode, we can use some JSON format. We can use this with the sliders. We can use this with some, like charts, everything that we can able to discuss, like whatever the uh, the the features or the attributes, whatever we are selecting and how it is predictions. So working everything that we can make it fine with this web application. This is the complete important of this Streamlit. So this is the most important work of the Streamlit. So we can do anything using this use cases in EML with the Streamlit. Like we can also do NLP, like say for example, sentiment analysis app. You can take where users, you can type the text and you can the model can be predicts the sentiment. And say for example, we can have it on the computer vision. So in this computer vision, you can upload an image even, and you can, and that model can detect whether this is object or the faces. And in the predictive analytics, you can enter the features like this is the predictive analytics where we are going to enter the features like where we can enter the features like, we can have the age, income, or something like that for the predictive analytics. And you can using this you can predict a loan approval, or you can predict the disease risk, whatever the disease risk, etc., that we can do it. And using this chatbots and the LLM, like chatbots, like you can integrate with the OpenAI and like having this hugging face. This is hugging face to create the AI assistant. We can do it. So these are the complete things about this Streamlit. And so using the Streamlit, we can have quick prototyping of the models. We can have the hands-on experimentation. So we can have this seamless visualizations as we discussed. And so we can have this user-friendly for the non-technical stakeholders, and in very importantly, easily deployment, like it is this whole machine learning project into completely, we can deploy it into a AML application. So it is completely free on a Streamlit cloud, or you can also host it in the GCP or Heroku or AWS something, and it is very ideal for the teaching and the training also. So in academic or any training, Streamlit is very, very perfect for the hands-on AML learning. So students or even the participants can play with the parameters, whatever we are using, the data sets and the models in real time, we can use it. So all the real time applications that we can apply it. So it is just, you can use it with just writing the normal Python code, and you're going to add all the UI components so far we have mentioned. So I'm just executing it. All the UI, it's just a Python, a normal Python code we are doing. And we are going to import all the UI components like text boxes. We have done with the sliders, we have done with the buttons, we have done with the AS file upload also we can do. So with one line of code that we done is also, we can easily integrate this with the pandas as I mentioned it. So pandas, even if you want to work with the numerical Pythons, numerical numbers, data sets, yes, you can use with the NumPy. And you can also explore this with, I have done here with the plotly.express for the graph to have a better graph. Yes, you can have the basic matplotlib graph is, yes, you can use with the basic Seaborn graph. You can directly import this scikit-learn also. You can directly import this machine learning algorithms. You can use linear regression, logistic regression, all the regressions in the classifications, even clustering. So everything over here on a very common platform that we can do. So this is a complete, from the model to the application that we have done, like building this AML web applications with the Streamlit. This is what we are doing. Let me move on to the show. Yes, so have done all these visualizations with line charts, everything, and have load the trained ML model. And we have accept the users inputs, that accepting those user inputs like sliders we have done. We have given the input with the sliders, and we applied the pre-processing and done the predictions, and we can display all those things with the charts, everything. So this is how we are predicting, and we have done with diabetes prediction applications. So just like we have trained this model, and we built this UI, user interface components, and we deployed it also. You can deploy it on if it is pre-Streamlit, you can deploy it on GCP anyway. And this is how you can train or use any machine learning model. So you can either train your own ML model, like ML model, any ML model, classification, regression, even NLP you can do. You are using image recognition, yes, that is also fine with TensorFlow, or you can also use with PyTorch, or you can use your pre-trained model also. The pre-trained model, like you can get it from the Hugging Face transformers or OpenCV models, etc. That you can do it. So once the model is trained, you usually save it in a file format. That file format is pickle. You can have joblib, H5, etc. for the later use. That is very important. Once you trained it, once the model is trained, that is very important to save it. So that option is very important. Like say for example, I can take a model that predicts house prices, like house prices based on the features like the area or the number of bedrooms or where it is located. So all those privileges that we can do it. So all these things done with the Streamlit basic commands, and you can build the web application using this user interface. Like there are so many widgets available for the Streamlit, like we discussed input widgets. Like there is file upload, there is a buttons, there is a display outputs, everything. Like say for example, you can give some input. I can give some based on this house price prediction. So we can give some input to the house size. Maybe I can give some bedrooms, some locations. So through the text boxes I can give, or through the sliders I can give, and I can, get the application done, get the result done based on this given components. And you can also load the model and also make the predictions. So model loading is by using the pickle, and very important to import the pickle before loading any data set. So after that, this will create a very simple interactive web applications where the user can enter the input, and they can also model the predicts. So that prediction, and finally you can result, the result is displayed. And there is, you can have the add-on features also. So there is visualizations, there is interactive dashboard, even you can upload the functionality. So interactive dashboard, which means that you can also show the model accuracy. So that also possible using this. So using this, I can say here prediction, applying the pre-processing. So where you can do the interactive dashboards that can show the model accuracy, the confusion matrix, or even the feature importance also. So once it is done, you can upload the functionality. Let users upload the CSV file or the batch predictions, etc. And finally, you can do with Streamlit Cloud. You can deploy with this Streamlit Cloud. So on the whole, the summary is about you can train or you can load any machine learning model. Using this, you can build a Streamlit applications with UI inputs and the outputs. And you can load the models inside the applications and you can make the predictions. Yes, you can add the visualizations, interactivity, and also you can upload the features. So also you can deploy the app online so the other users also can use it. So all these things will happen. And using this Streamlit, I can say it does together you get a AI powered interactive application, like it is going to build the intelligence, or I mean I can say it is going to build the model, and that makes that intelligence usable, also usable in the sense like based on the web applications. And this is what the Streamlit is. Thank you so much. Yes, any questions you're having, we can see. Any questions and answers?
Yes, Samudra, I think we have two questions so far.
Yes.
Okay, so the first question is, how did you do training and testing dataset split?
Can I, for example, yes. First question is also, for example, random forest or SVM. Which algorithm did you use? For example, random forest or SVM. Okay. So I have used the example of SVM for this diabetes prediction, not the random forest. Yes, this was the first example, I mean, first question. And the second question is how to Okay, 1 minute. How did you do training and testing? Yes. So this training and testing have done completely into the like machine learning. I mean, any Python IDE which I'm using. So currently I have done with the Jupyter Notebook and I've displayed with the Colab. So you can do the training and testing in the IDE integrated development environment, and you can convert that into the application format using the Streamlit. So testing and training part should be done in the integrated development and environment. And if you want to do it in the directly application, if you want to display in the direct application, so please you can import any scikit or TensorFlow applications or the libraries directly into the like in the web applications of the Streamlit. That you can do it. Yes, yes, Ankita.
Thank you very much, Ms. Samuda, for such an insightful and engaging session. And to our attendees, it's been wonderful having you with us today, and we are grateful for your participation. Now, if this session has encouraged you to explore more on building AI and ML web applications with Streamlit, I invite you to look at our virtual instructor-led training programs at springpeople.com. These are live sessions conducted by certified trainers and can be attended from the comfort of your home. Now, if you do not find a batch that matches your schedule, we can arrange private group sessions or recommend flexible self-paced courses that you can take at your convenience. Now, for more details, you can write to us at training@springpeople.com or call the number on your screen. Our team will be happy to guide you further. Now, to everyone who joined us today, thank you once again for your active participation. The recording, as one of the participant has asked, will be sent to your registered email address shortly. Please do keep an eye out for it. Now, before we close, we would love to hear your thoughts about today's session. Please take a moment to share your feedback with us. Your review will help us improve and make our future sessions even more valuable for you. Until next time, keep learning and we look forward to having you in another Spring People session.